Hello everyone, welcome to Bodhi Academy. So today we will learn the important formulas proof from the chapter integration. So two proof already we have done. Now the third proof of integration. So integration of dx upon x square plus a square, that is nothing but 1 upon a tan inverse of x upon a plus c. We have to prove this. So let's start with LHS. LHS is equal to, given, we can write down like this, 1 upon x square plus a square into dx. Okay. Now look at in the RHS what we need, 1 upon a tan inverse of x upon a. So we need tan inverse. Okay, so here in this integration we have to substitute something like that. So let's take x is equal to, here we need a also, so let's take a x is equal to a tan theta. Okay, so now we have to convert this integration in terms of theta. So derivative, if we take the derivative with respect to theta, so this will be dx is equal to a as it is, a is any constant, derivative of tan theta, that is nothing but sec square theta d theta. So this substitution we will do it here. So integration 1 upon x square, so instead of x we have to take a tan theta, so a tan theta raised to power 2 because it is x square plus a square as it is, and dx is there in the numerator, so the value of dx is nothing but a sec square theta d theta, so that we will take it here, a sec square theta d theta. Now in the denominator, numerator as it is a sec square theta theta divided by, here a tan theta the whole square, that means it is nothing but a square tan square theta plus a square. So in the denominator you can say that a square is common, so in the denominator we will take a square common, so a sec square theta d theta as it is. In the denominator if we take a square common, so we will get inside the bracket tan square theta plus 1. Okay. And we know that the identity from the trigonometry chapter, 1 plus tan square theta is nothing but is equal to sec square theta. So this identity we will use here. So numerator as it is a sec square theta d theta divided by a square, and this is 1 plus tan square is nothing but sec square theta, that is sec square theta. Okay. So from numerator and denominator sec square theta will get cancelled, so it will remain, and 1a will get cancelled, so 1a will remain in the denominator, that will take outside, so 1 upon a outside, integration of d theta, and integration of d theta is nothing but theta. Okay. So 1 upon a as it is. Now what is the value of theta? So in the starting we have taken x is equal to a tan theta, so we need to find out theta from here. So if we take this a in the denominator, so it will become x upon a is equal to tan theta, but we need theta only, so if we take this tan this side, it will become tan inverse of x upon a is equal to theta. So the value of theta is nothing but tan inverse of x upon a, so we will put it here, so tan inverse of x upon a, that is nothing but our RHS. Okay, so what we have done here, we need here in the RHS tan inverse of x by a, so we have taken x is equal to a tan theta, substitute in place of a x a tan theta, then apply this identity 1 plus tan square is equal to sec square, then we will get the answer. Okay. Come to the next one, it is 1 upon integration of 1 upon square root of x square plus a square. Now what is the change here, x square plus a square, the same thing is there, but now it is inside the root. The only the change is we have root here. So the same process we have to do, we have to substitute something, so we'll get the RHS. Okay, so let's start with LHS. So LHS is nothing but integration of 1 upon square root of x square plus a square into dx. Okay. So again here also the same thing we will do. Instead of x we will take x is equal to a tan theta. So dx is nothing but a sec square theta d theta. Now we will substitute this thing here. So integration in the numerator 1 into dx, that is dx, so the value of dx is a sec square theta d theta. In the denominator, just square root is the new thing, remaining thing as it is. X square means a square tan square theta plus a square. So again the same thing, take a square common in the denominator, so numerator as it is, divided by inside the square root. If we take a square common, so in the bracket will remain tan square theta plus 1. Okay. And we know that by using the identity, 1 plus tan square theta or tan square theta plus 1 is nothing but sec square theta. Okay. So inside the root, a square into sec square theta. Now numerator again as it is, a sec square theta d theta divided by, now the square and root will get cancelled, so a square root of a square sec square theta is nothing but a sec theta. Okay, so from numerator and denominator a will get cancelled, 1 sec theta will get cancelled, so what will remain? Integration of sec theta into d theta. Okay. Now we have to just use the formula of integration of sec theta, that is nothing but log of sec theta plus tan theta plus c. Okay. But now we need in the RHS log of x plus square root of x square plus a square. Okay. So how to find proof that's log of x plus square root of x square plus a square? So just we have to replace this, the value of sec theta and value of tan theta. We have to find out the value of sec theta and tan theta, and we have to substitute here. So what we have taken in the starting, x is equal to a tan theta. So that means tan theta is equal to x upon a. Okay, so we got the value of tan theta. Tan theta is nothing but x upon a. Now we need sec theta. So we have identity 1 plus tan square theta is equal to sec square theta. So we will substitute the value of tan theta here. So 1 plus tan theta is nothing but x upon a. So tan square theta is nothing but x square upon a square. Okay. And we needed only sec theta. So if we take this square, this side will become root. Okay. Sec theta, the value of sec theta is nothing but square root of 1 plus x square by a square. And if we do the cross multiplication, we will get a square plus x square upon a square is equal to sec theta. And the denominator a square is there, so root of a square is nothing but, we can write down like this, in the numerator root of a square plus x square divided by a, because square root of a square is a. So we have the value of sec theta and we have the value of tan theta, so that we will substitute here. So log of sec theta is nothing but square root of a square plus x square, or you can write down x square plus a square, that is the same thing, divided by a, plus value of tan theta is nothing but x upon a plus c. Okay. Now here denominator is equal, that is a, so we can add the numerator. So this we can write down x plus square root of, we can write down x square plus a square, okay, that is the same thing, divided by whole divided by a plus c. Then next we will apply here log a upon b, property of logarithm. So that is nothing but log of a x plus square root of x square plus a square, this is a. Okay, what is the property of log a upon b? Log a upon b is nothing but log a minus log b. So numerator is a, denominator is b, so log a minus log b, that is log a plus. So this part as it is, log of x plus square root of x square plus a square, that we want, and this is a constant part, so let's say this full thing is nothing but c1, that is a constant. Okay, so minus log of modulus of a plus c, that is we have called name c1. So this is our RHS. Okay. come to the next proof. So it is the similar type, the same thing, whatever we have done in the last proof, the same idea is there. Instead of here, what is the change here? Instead of plus, here we have minus sign. That is the change. So again we will start with the same thing. So LHS is equal to integration 1 upon x square minus a square dx inside the root. So let's take x is equal to a tan theta. So dx will be a sec square theta d theta. So we'll substitute here. So integration dx, in the numerator dx is there, so a sec square theta d theta. In the denominator, what will get? Square root of x square. So x square will be a square tan square theta minus a square. So in the denominator we will take a square common. So a sec square theta d theta divided by, in the denominator if you take a square common, so a square inside the bracket tan square theta minus 1 will remain. Okay. So here tan square theta minus 1, and we have the identity 1 plus tan square. Okay, so here this thing we cannot take. So because we cannot use the identity here 1 plus tan square, so that's why we cannot take x is equal to a tan theta here. So now what we can take? See, we have identity 1 plus tan square theta is equal to sec square theta. In the last two proof we are getting 1 plus tan square theta inside the bracket, but here we are getting tan square theta minus 1, so we are not making out the identity, so we cannot take x is equal to a tan theta. So here we cannot take x is equal to tan theta. So what is the change here in this? We will take x is equal to sec theta. Why sec theta? That I will tell. So here in this question we will take x is equal to a sec theta. Okay. So what is the derivative of sec theta? A derivative of sec theta is sec theta into tan theta d theta. Okay. So now by using this, let's check we will get the answer or not. So dx is nothing but a sec theta into tan theta d theta divided by, inside the square root, x square. So x is nothing but a square sec square theta. Okay, because x we have taken a sec theta, square of that is a square sec square theta minus a square. Okay. So integration a sec theta tan theta d theta as it is divided by, inside the square root we can take a square common, so a square common, so inside the bracket we will remain a sec square theta minus 1. Okay. Now this is, we can use the identity here. Okay, so we have identity 1 plus tan square theta is equal to sec square theta. So if we take this one that side, so it become tan square theta is equal to sec square theta minus 1. Okay. So it is satisfying. So you don't have to remember all this proof, you have to just check what way to take, so we will get our answer. So sec square theta minus 1 is nothing but tan square theta. So here we will apply numerator as it is a sec theta into tan theta d theta divided by, inside the root, a square as it is sec square theta minus 1 is nothing but tan square theta. Okay. And now numerator as it is a sec theta tan theta d theta. In the denominator, root and square, this square root of a square, that is a, and square root of tan square, that is tan theta. So this a will get cancelled, tan theta will get cancelled. So what will remain? Integration of sec theta and d theta. And we have done in the previous proof, integration of sec theta is nothing but log of sec theta plus tan theta plus c. And we know that from here we will find out the value of sec theta, because we have taken x is equal to a sec theta. So from here the value of sec theta is nothing but x upon a. And we need the value of tan theta also. So by using this identity, okay, by using this identity, we will find out the value of tan theta. So tan square theta is equal to sec theta. Sec theta is nothing but x upon a. So sec square is nothing but x square upon a square minus 1. And we need only tan theta. So tan theta is nothing but square root of x square if we do the cross multiplication. So x square minus a square upon a square. In the denominator a square is there, so root of a square is nothing but a. So square root of x square minus a square divided by root of a square is a. Okay, this root is full. The square root of denominator, that is a square, is a. So substitute this value, log of sec theta. The value of sec theta is nothing but x upon a, plus the value of tan theta is square root of x square minus a square upon a plus c. Again the same step we have to apply. Denominator is equal, so add the numerator. So log of x plus square root of x square minus a square whole divided by a. Okay. Then apply the log a upon b property. So log of numerator, that is x plus square root of x square minus a square minus log b. So log b is nothing but in the denominator, that is a plus c. And this is full constant part, so let's take that is a c1. So this log of x plus root of x square minus a square as it is, and this part is we have taken c1. So this is nothing but our RHS. Come to the next proof. Integration of 1 upon square root of a square minus x square. Now the change is here, a is first and x is later, and we need to show that it is equal to sine inverse of x by a. So in this proof we need sine here. Okay, so what we have to take, x is equal to, that you can now take the idea, we have to take here x is equal to a sine theta. Okay, so let's do it. LHS is integration 1 upon root of a square minus x square dx. So we need to prove that is equal to sine inverse of x by a. So let's take x is equal to a sine theta. So what is dx is equal to a derivative of sine theta is cos theta d theta. Okay, and from here we can find out the value of theta also. X is equal to a sine theta, then theta is nothing but sine inverse of x upon a. Okay, we will get theta is nothing but sine inverse of x upon a. How? So x is equal to a sine theta, so sine theta will be x upon a. Okay. So if you take inverse that sine that side, it becomes sine inverse of x by a. So substitute this value, integration in the numerator dx is there. Dx means a cos theta d theta divided by square root of a square minus x square. So x is a sine theta, so x square will be a square sine square theta. Now again the same thing in the denominator, a square we have to take common. So a square we will take common. So inside the bracket what will remain? 1 minus sine square theta. And we know that identity, sine square theta plus cos square theta is equal to 1. So here we have 1 minus sine square theta. So if we take this sine square theta that side, so what we will get? Cos square theta is equal to 1 minus sine square theta. Okay. So integration a cos theta d theta as it is, cos theta d theta divided by square root of a square, and 1 minus sine square is nothing but cos square theta. Okay. Now integration a cos theta d theta as it is in the denominator square root of a square, that is a, square root of cos theta, that is cos square theta, is cos theta. So a will get cancelled, cos theta will get cancelled. So what will remain? Integration of d theta, and integration of d theta is nothing but theta. And we know that what is the value of theta? Theta is nothing but sine inverse of x upon a. So that is equal to our RHS. Okay. So this is a standard formula of integration proofs, and that is very easy. You don't have to remember any proof. Just what we have to prove in RHS, according to that you have to substitute the values of x. Okay. So thank you everyone, and if you are like our video, then please do this, share and subscribe our channel.